So now we're going back to the Azure Data Studio and start running some scripts. In this Azure Data Studio, you can easily find out your connections and your database and database objects. If you look at this top little icon here, connections, if you click on that, it will show you which database servers you're running on. And I have this 2017 version sitting here, and I got my 2019 version. So what I can do is I can just click here and it will expand out, much like you see in SQL Server Management Studio. It's pretty much the same thing, as you can see. And then you can drill into the databases you're interested in, and you have all the objects listed like so. You know, I can look at my tables. I can look at stored procedures and so forth. So that's a nice little way of navigating through some of this stuff. The first R script I want to run is using this performance analytic package. Now, I put it in here. I don't think it's needed. I think you'll get away with just putting this one package in because it's supposed to be loading the others, but I don't know. I just put it in there. So this script, this R script, is going to use this Tidyquant and all its supporting packages. Like in particular for this part, it's going to use a package called QuantMod. And in QuantMod, there is something called get symbols. And the wrapper that this Tidyquant is using, the function wrapper that is using over that is this tqget. And what it's expecting to see is a ticker symbol, in this case, the S&P 500 ticker symbol that comes from Yahoo Finance. And the type of get you want to do, you're going to look for stock prices. This method has more than just stock prices you can go and look at. But for now, let's just look for stock prices. I also have a from time frame, and I'm starting in January 1st, 2013, and I'm just going to run this up through whatever the latest date there's data for. So this will be in 2020, in February, the 26th today. So it will probably pick up at least 25th. And then I create a variable that's going to hold the data for each one of these ticker symbols. So as you can see, I got a few mutual funds. I got some pharmaceutical companies here. This is Abbott. This is AbbVie. These are some Janus funds. And I got the S&P 500. Then what I do is once I get the data, I want to bind the data together. So all of these result sets, I want to bind them together, create a new row descriptor for each one, and just add them as new rows, one stacked on the top of the other. And that will create a data frame called data. And then this generic value output data set variable that SQL Server uses is going to actually return the data frame back out to SQL Server. And again, you use this external script. Store procedure, language is going to be R, and this script variable that I created up here is going to contain this string that we're going to actually execute. So when I run this now, it's going to go out on the internet, download all this data, and it's going to create a data frame and return it to SQL Server. And now it's done. And as you can see, you're getting some error message, warning messages, and so forth back. But as you can see, it went out there and it got the data. So here I got the stock symbol, but we don't know what these columns are yet because we haven't really fixed it up yet. That will be what we're going to do next. Okay, so now we got the ticker symbols, and we got some columns we don't know what is. There's also something funny here. I'm not quite sure what this is, but we'll figure it out. So let's now go and remove some of this output. So I'm going to go Control-Shift-R to get out of that. And what I want to do now, I want to take it to one more step and improve on this data frame that we just returned to SQL Server. So this is the same script, but I made one little change. Actually, I made two changes. This data frame that I loaded with all these rows, I want to fix up the date column, and I'm going to make it as a character string. So I'm going to convert the date column that sits in the data frame into a character string and place the values that I'm converting it into in the date column itself. Then I'm going to return the data back to the data frame, back to SQL Server. Another thing I've done now is I have created this with result sets. And what that allows me to do, it allows me to actually create column headers for the data that SQL Server can understand. So this symbol is the ticker symbol that comes from here. And when I ran this in R Studio, I can see exactly how many columns and what they are coming back. So the columns that comes back from this, Yahoo Finance is symbol, it's the date, it's the open, high, low, close prices, the volume, the trading volume, and the adjusted price, meaning it's been adjusted for stock splits, etc. So now that I got these columns, I can run this again. Again, it's going to run out to your internet and get the data again. So it's a little redundant, but it's just for the demo. I'm doing this. And once it's done, as you can see, now it actually came back with headers. So now we got symbol, date, open, high, low, close, volume, and adjusted. And that's all fine and dandy, but this is still setting as a string variable. So next, what I want to do is I want to see if I can fix that even more. Okay, so now we got the actual data back. And what I want to do next is I want to take a look at this R to SQL Server mapping data types. That's it's kind of important you need to know about. So I put out a link here. So when you click on that, it will take you to this web page here. And in this web page, data type mappings between R and SQL Server. If you scroll down on this web page, you can see there is something called implicit data type conversions between R and SQL Server. And it will tell you the SQL type, and it will tell you the R class. So the one I care about right now is I want to return a date from the R code. And I need to know how do I do that, because I only used the character string before. And initially when we did do nothing, we came back with a number, just a serial number. As it turns out, it tells us here that in order to create a date format in SQL Server, you have to convert it to this format, this POSIX CT format. So what we can do is in our R code, I have this script here, and inside this script, there is a function called asPOSIXCT. I'm going to simply take this data frames date column, which is by $date, and convert it into an actual POSIXCT date. And I'm going to set that into that column again. So that will be overriding whatever values was there before into this format here. And then I'm going to return the data as a data frame out to SQL Server. Another thing I'm doing in here that we haven't done before is that I'm going to create a table, and the table is called stocks, and I'm going to put it inside this test DB. And I have one additional column that is not in that data frame. It's called returns. And I make all of these float variables, except for the ticker. I make a varchar 50. And this date now, I'm making it into actual date format. So down here, I'm inserting into this table that I created. And I simply leaving out the returns because those are going to be initially be null. And I'm executing my script. I also give the output data. Instead of using that output variable I've been using up till now, I give it a specific name. And you can do that by using this output data one underscore name. And I'm calling it data out. And therefore, I can set my SQL Server data frame return object equal to that R data frame that I'm creating up here. So I'm going to go ahead and insert the data into my table. But before I do, I want to remove anything that sits in this table. I already created this table. So let me truncate that. And now let me run this insert statement. And it's spinning along. And it came back. And it told me that 14,392 rows were inserted here. So that's how you can actually insert records from the R script into a SQL Server table. What I want to do now is I want to actually put some values into this return column, because right now it's empty. And if you query it, you're going to see, so the return is null. And what I want to do is I want to compute the return inside SQL Server. You could do this in R as well, but I decided to mix it up a little bit. So I wanted to kind of compute it in SQL Server. So how do you compute this return? Well, there's a couple of ways of doing this. One thing you can do here, if you want to test this out, you can say save as Excel, and you click here, and then you save it with the results XLSX, and it goes into this folder here, whatever you put it. And then you can just open this one, and it opens in Excel. And when you do, you're going to see something that kind of looks like this. It didn't have any header when I saved it, so I had to go back in and put these in. But you have the date, the ticker, and then you have all this open, high, low stuff. The one I'm interested in is adjusted here, and the dates. So as you can see, it's sorted in ascending order here. Earliest date first, and the next for this Standard & Poor's ticker. So there are two ways you can compute these returns. There might be more, but I'm going to focus on these two. One is a so-called simple return, and one is called a log return. Another word for this is continuous compounding rate of return. This simple return, you will start with, because there's no date before here, there's nothing to compute against. So you have to start here because you have a daily return here. So you start on the 3rd, and you want to compare it to the 2nd to figure out how much it changed, the price, the adjusted price changed between those dates, and get a percentage out of it. So the way to do that is you start in this I3 cell. So I take this H3 minus the H2, so the current minus the original or the previous, divided on the previous. That will give you the percentage, and that's how you compute the simple rate of return. The other one you can use is the log return, which is continuously compounding. And the way you do that, you use the log function. And in Excel, you use this ln function, and you can open it and you can look at what it is by clicking on it, and it will take you to this page. And this computes the natural logarithm of a number. So that's why we use this ln function to compute the log return. And again, you take the current adjusted price, and you divide it on the previous one, and you take the log of this. That's how you can compute the rate of return. And that's what we're going to do in SQL Server. We're going to use this log function to figure it out. And we also have to factor in that this first date does not have anything to compare against. So we have to take that into account when we do the formulation. So that is what I'm going to do next. So now I want to calculate the rate of return, and I want to use the log rate of return. So what I have here, just to test this, I want to run a select statement first. So I'm going to query against my stocks table that I just loaded, and I'm going to bring out some columns so I can see as part of the result set. But then I'm using this case statement. So case is like an if statement, if you will, inside this query. And it says when the date column is equal to, and then I'm using a cast function to cast a string variable that represents the first date that I queried for in Yahoo Finance, which is 1/1/2013. The data came back, but it came as of 02. So this is the first date for every one of these tickers that I have in my table. So I want to cast that as a date type. and I'm going to compare it to the date column. So if those two are the same, if they're equal to one another, then I want to simply leave it at null in this return column. Otherwise, I want to calculate the log return of the adjusted, the current cell, or the current row, if you will, for the adjusted price. And I want to use a analytical function, a Windows function, as sometimes called in SQL Server. In Oracle, they call them analytical functions. I'm going to use the lag function for the adjusted price. So that will take the previous row. So in effect, what it will do is, because we leave this at null here, it will take 213.01.03. So it'll be the third day, and it's going to be compared to the price on the second date. And that's what this lag function is doing, because I'm lagging it by one row. So there's that one here. And then I do an over clause, and I sort it by ticker symbol and date. And what I do after I compute this log return, I simply round it up to 8 digits. And that's what this else statement does. And then I simply end the case statement, and I make the column name return. Now I can run it. Okay, so it returned the top 5,000 rows. So that's how you compute the log return over this series in SQL Server. And when you scroll down here, if you scroll far enough down here, on the first day, the second, Avi has null in here as well. So next, I want to take care of this. I want to remove these records because I can't really use them for anything. So I'm just going to delete them out of there. But before we do, I want to update the table with these return values. I just ran the select statement, but now I want to actually update the table. So that's what I'm going to be doing now. So I wrote this update statement. I'm setting the return equal to one thing in SQL Server you can't do. You can't use Windows functions in update, insert statements, etc. So what I have to do is I have to have a subquery to get the values. So I'm doing a select date ticker, and then I have my case statement we just looked at here. So that will make the return. And then I do it from this table. And I call this new subquery X. And then I say where the ticker in the stock table is equal to the ticker in this X subquery. I'm setting the date equal to the subquery's date. So I'm linking them on ticker and date. That way I can match row by row which one I want to update. And then I say update this table, set this table's return value equal to the return value in the subquery here. And let me try to run it now and see if it picks it up. Okay, so it updated 14,392 records. Now we can look at the return here by running a plain vanilla select statement this time from this table. So I'll run that. And sure enough, you can see the results here. They're coming back with the return in the table now. However, we need to deal with this first date. And what I want to do to clean that out, I'm going to write a delete statement from this table where the date column is equal to compared to 2, and those are the records I'm deleting. So when I run this, 8 rows was affected, and we should have removed those now. I can quickly test this by running the select again. And looking at it now, you can see it starts on the third here, and the second is gone. So now it's cleaned out again. So I am back in R Studio, and I wanted to next run some calculations using the Performance Analytics package. And what I want to do is I want to show you how you can look at the different things that the Performance Analytics can perform, meaning the metrics, and so it can produce charts, etc. So if you click on this Performance Analytics package, you can see it's an econometric tool for performance and risk analysis. It has quite a bit of information in it. And as you can see here, there's all kinds of functions that it uses, financial functions and econometric functions. The easiest way to get familiar with this is to probably go into these vignettes. And when you click here, there's a list of those you can look at here. I'm going to just grab one, this one here, and I'll open it up. And this one gives a description of the different tables it will produce for you, different output, and it gives you an example. And this data set comes with the package, so you can practice all this by using that data set. Charts it can produce. So they have all kinds of nice charts you can create. And there's also tables you can create, like you can create calendar returns, like by using this syntax here and passing in your data. And it also has all kinds of statistics, variance, standard deviation, skewness, kurtosis, and the symmetry of the distributions you can look at here. And these are all available as part of this package. The one that I wanted to try to run is a table that is called CAP-M. So this CAP-M table comes with all these different metrics. And in the performance analytics package, these metrics are in a row format, and then the tickers, if you will, are in a column format. But we're going to see that SQL Server orders this a little differently. So I'm going to be running this particular function in SQL Server next.